So we will come back with JavaScript syntax and features necessary for us to deeply understand the modules that we are discussing. Modern JavaScript syntax and features. Some fundamental changes were introduced to JavaScript syntax with ES 2015 that are especially relevant to our discussion on patterns. These are covered well in Babel.js ES 2015 guide. So because ES 2015 added a module rather in their built-in feature, so that significantly changed the trajectory of design pattern. It made the design pattern more clean in the modern JS. This book relies on modern JavaScript syntax. You may also be curious about TypeScript. TypeScript, a statistically typed superset of JavaScript, offers several language features that JavaScript does not. These features include strong typing, interfaces, enums, and advanced type interface inference, and can also influence design patterns. So it's different from TypeScript. There's some advanced pattern from TypeScript that is not in JavaScript. In that case, the design pattern will slightly be different than JavaScript. To learn more about TypeScript and its benefits, consider checking out some O'Reilly books such as Programming TypeScript by Boris Cherny. So basically, TypeScript has changes some things, but the basics are still from ES 2015 JavaScript. The importance of decoupling applications. Modular JavaScript allows you to logically split your application into smaller pieces called modules. A module can be imported by other module that in turn can be imported by more modules. Thus, the application can be composed of many nested modules, similar to the many different mixins we discussed in the previous chapter. In the world of scalable JavaScript, when we say an application is modular, we often mean it's composed of a set of highly decoupled, distinct pieces of functionality stored in modules. Loose coupling facilitates easier maintainability of apps by removing dependencies where possible. If implemented efficiently, it allows you to see how changes to one part of a system may affect another. The keyword is if implemented efficiently. Of course, this built-in design allows you to to see that easier, but at the same time, you could also you can also misuse that if you do it in another if you go over it, or if you did not use it properly. So unlike some more traditional programming language, the older iterations of JavaScript until ES5, standard ECMA 262 5.1 edition, did not provide developers with the means to organize and import code modules cleanly. So with Java, C++, etc., they provide that even with their first versions. So JavaScript is not really do not really provide that do not really provide that at the start. So it doesn't have this built-in features. But there's some techniques that you could do to be able to do that, which we will discuss in the next videos. It was one of the concerns with the specifications that had not required great thought until more recent years, when the need for more organized JavaScript applications became apparent. AMD, asynchronous module definition, and common JS modules were the most popular patterns to decouple applications in the initial versions of JavaScript. So these modules are actually the pattern they use instead of this new pattern that we have now, since the built-in has changed. They have this module to use as their pattern. Native solutions to this problem arrive with ES6 or ES 2015. TC39, the standards body charged with defining the syntax and semantics of ECMA script and its future iterations, had been keeping close eye on the evolution of JavaScript usage for large-scale development, and was acutely aware of the need for better language features for writing more modular JS. The syntax to create modules in JavaScript was developed and standardized with the release of ECMA script modules in ES 2015. So these native solutions was actually arrived in ES6 and ES 2015. The standard body or the organization charged or tasked with defining the syntax and semantics of this. So the semantics, we will go deep into that because that's basically what we are doing here. It's important for us to learn the semantics first before we learn the syntax. Kind of like learning the meaning of something before you are able to describe it through words. Like you need to know if, like, for example, something like you want a milk, you know the meaning of the milk, it will help your body before you're able to describe that word as a child. So that's basically what semantics and syntax difference means. So in its future iterations, I've been keeping a close eye on the evolution of JavaScript usage for large-scale development, and was acutely aware of the need for better language features for writing more modular JS. The syntax to create modules in JavaScript was developed and standardized with the release of ECMA script modules in ES 2015. So that's the reason why this modules has been, or the semantics, this module we're talking is just semantics, has been invented by those organization tasked to do so. The syntax to create modules in JavaScript was developed and standardized with the release of ECMA script modules in ES 2015. Today, all major browsers support JavaScript modules. They have become the de facto method of implementing modern-day modular programming in JavaScript. Modules with imports and exports. So this is the basics of modules. This is the semantics. Modules allow us to separate our application code into independent units, each containing code for one aspect of the functionality. So just like with this built-in feature separate the code naturally compared to without this built-in feature. It's the same with an ORM, in which, like, instead of worrying about the way our application code will connect to our database query, we just have this middleware that allows us to connect. So it's basically like helping us to be more productive because it abstracts a lot of complexity from us. It helps us to organize it organically. Modules also encourage code reusability and expose features that can be integrated into different applications. So another benefit is that it encourages code reusability and expose features that can be integrated into different applications organically. Import declarations bind a module export as local variables. So if you import something or like a mixin from other modules, it binds that as a local variable. So you take that to be as your local variables and may be renamed to avoid name collisions or conflicts. So you can rename that to avoid that naming it was declared from that module where you imported it, or from other modules that may have defined that module in other, that variable in other parts of the app. Export declaration declare that a local binding of a module is externally visible such that other modules may read the export but can't modify them. So when we see when we export or declare a variable or a function or a class, it means other module can see it or can use that particular variable, function, or module we export. Interestingly, you can other modules may read that exports variable, but they can't modify it. So they may read the value of that once instantiated, once that object is instantiated, but they can modify that internal value unless that your module itself modify it. So interestingly, modules may export child modules but can't export modules that have been defined elsewhere. You can also rename export so that their external name differs from their local names. Let's just continue with this.